Okay, so this one here, we're going to do the same thing. We're going to do an inside restriction and outside restriction. Okay, so our domain from the inside, we know that 2x squared must be greater than or equal to 1. So x squared must be greater than or equal to 1/2. So we get x is greater than or equal to square root of 1/2. And also must be less than or equal to negative square root of 1/2. Remember that when we undo the square, we have to get the plus minus version. And so if it's more negative than negative square root 1 over 2, we're going to get a number. When we square it, we're going to get a bigger number bigger than 1/2. Okay, so that would be satisfy that inequality. The outside restriction, again, we want to base that off of the square root, what the square root equals, okay, the outside of the square root equals, and we can say that x must be greater than, it must be less than or equal to 12, okay, because if it's bigger than 12, we're taking away more than 12, which is going to give us negative. So based on these restrictions, it's got to be less than, this is going to be a little bit complicated, but let's maybe deal with this afterwards. We'll just solve this first. Okay, so I'm going to square both sides. So I end up with 2x squared minus 1 equals 144 minus 24x plus x squared. Combine like terms, so subtract x squared from both sides, add 24x to both sides, subtract 144 from both sides, and I'm going to be equal to 0. So I'm looking for two numbers that multiply to 145 and have a difference of 24. Ooh, that's a little bit tough. Maybe 29 and 5. Okay, I think 29 and 5 would do it. So x plus 29, x minus 5. Okay, if you're not sure, you could have put it in quadratic formula, and you end up with the same solutions. I'm just going to double check this here. So negative 5 times 29, yeah, that gives us negative 145. Okay, so those are our factors, and we can get our solution. X equals negative 29, x equals positive 5. Okay, so we know that the solution has to be bigger than square root 1/2, and also less than negative 1/2. Okay, so this satisfies one part, okay, and it satisfies less than 12, yeah. Okay, so it seems to satisfy this one here, this one here, less than negative 1/2 square root, okay, and then satisfies this, so negative 29 looks like it's okay. 5 is bigger than square root 1/2 and less than 12, so they both appear to be okay. Okay, now that's kind of complicated, the domain restriction here. Okay, let's just test it, then we'll go back to the domain restriction. So let's test. Let's go ahead and test our solutions. This is much easier. We're going to test x equals negative 29. Plugging in x equals negative 29, okay, I'm going to end up with, I don't know what negative 29 squared is, but we have a calculator for that. Okay, so I'm going to end up with the square root of 2 times 841, which is x squared, minus 1, plus negative 29 equals 12. Okay, so 2 times, okay, and then minus 1, square root of 1681 is 41. So we end up with 41 plus negative 29 is equal to 12. Yeah, 12 equals 12. Yeah, we're all good. So that is perfectly good solution. We're going to test x equals 5. Okay, so we had 2 times 5 squared is 25 minus 1 plus 5 equals 12. Okay, so 2 times 25 minus 1 is 49 plus 5 equals 12. Square root of 49 is 7 plus 5. We get 12 equals 12. Again, perfectly good solution. Okay, so that's probably the easier way to do it, is just actually test it. But again, we do want to start kind of having an appreciation for this the domain restriction. So I'm just going to draw the domain restriction on a number line. So we know that it's got to be less than negative square root 1/2, and it's got to be there, and it's got to be bigger than positive square root 1/2, and it has to be, I'm going to put the 12 over here, negative 12, it's got to be less than 12, and it's got to be part of the overlap of those sections. So it's got to be somewhere in here. Okay, it's got to be less than negative square root 1/2, which that is, yeah, it's less than, and it's less than 12. And then the 5 is again bigger than the square root positive 1/2 and less than negative 12. So it's in this region here. So both solutions end up being in the domain regions that are acceptable. Okay, so again, this is a little bit new, and we'll do this a little bit more later on when we get into inequalities. But we can analyze these domain restrictions in this way. For now, we probably want to rely on the testing method. Just plug it in and check. Right, that is kind of the simpler strategy, because what we're doing is using numbers and calculating versus analysis. And we eventually want to get to analysis, but plugging in numbers and calculating is very reliable. It's cumbersome, it's time consuming sometimes, but it is very reliable.